and I am starting this series so that I can share my ideas and also just to be consistent and just to post these questions and my explanations and just to store them. So that's why I'm starting this series from 1st of February. I hope I'll continue to do this for a long time. So let's get into the problem. So the problem is divide an array into subarrays with minimum cost 1. So the question says that you have been given an array of n length. Now you have to divide the array into three disjoint contiguous subarrays. Now what does disjoint contiguous subarrays mean? Disjoint contiguous subarray means that you have to choose continuous elements and form a subarray, and you cannot overlap. Disjoint means you cannot overlap the subarrays, and contiguous means like you do not have to miss any element in forming the subarrays. Like for example, if we have 1, 2, 3, and 12, then we can say that a possible way of forming three disjoint contiguous subarrays is 1, 2, and 3, 12 in a single subarray. Another is 1, 2 in one subarray, 3 another, and 12 in third subarray. So that's how we have to divide. And now we have to divide such that it has a minimum cost. The total cost with dividing in the total cost should be dividing these three subarrays should be the minimum. And now what cost is? Cost is the first element of each subarray. So if I divide the this subarray into three parts, like first subarray is this 1 to 2, so the cost will be 1. Then I divide this into 3, only 3 in this subarray and only 12 in this subarray. So the cost will now be 1 plus 3 plus 12. It will be 16. So that's a possible way. Like here it's mentioned also, it will be 16. But the most optimal way is like if we form three subarrays which are 1, then 1, then 2, and then 3, 12. So the cost will be 1 plus 2 plus 3. So it will be 6. So what I initially thought, like the most initial thought which came to my mind was, should I try to sort? But that was completely wrong thought of line. So I immediately discarded it because then the subarray order will be disturbed. We have to maintain an order of the subarray. So we can't do that. And since we analyze the constraint that the constraints are only till 50, the length of the array is only till 50. So I decided to do a recursive approach, which was like I go to every element and I ask to every element that can I continue to include you in my ongoing subarray, or should I end and start a new subarray from here? So earlier, when I did this thing, so it was not including the first one. Uh, when the like in this example, it was not including the first element because what my original code was doing, like it was skipping the first element to make this minimum. But when I modified the code and had a thought over that, then I came to know and I realized that the first element should always be included. Because if first element is not included, then you cannot form a contiguous disjoint subarrays. So what I added in my condition was that originally the take is a big value like 1e9 here, and only we can skip the value when I is greater than 0. Obviously, it will not be less than 0 because we are starting it from 0. So I put this condition like if I is not equal to 0, then take equal to solve I plus 1 count for nums. And this is my start. Like if I have to start from that particular, like I am starting a new subarray, then I add the first element into the cost and I do I plus 1, move to the next index, and I also increment my count by 1. So what this will be doing that my one subarray is formed. And similarly, if I uh, continue to add that element in my subarray, this I have written in a take variable. So that I have written like if we are continuing to add it, no need to add the cost because it is not the first element, and we move to the next index, and no need to increment the count because number of sub-array count is not increasing. And then we have some nums, and I return the min of both. And here I wrote the base case like if I reaches to the end of the nums array, so we check that if count is equal to 3, because we only need three disjoint contiguous subarrays, then we return 0. Otherwise, it's an invalid path. So we return a big value like 1e9 here. So when I tried to submit this, the sample test case was were running fine. But when I tried to submit this, I received a TLE because of this large, not quite large, but it is large because we are like doing 2 2 raised to power n time complexity here, because at every element we have two options, either to take it or to not take it. So at every element we have two options, so 2 into 2 into 2 into up to n times. So the time complexity may lead up to 2 raised to power n, and 2 raised to power 50 is quite a high number, but so it can go up to that. So I can memorize it and make it n into count, and count will be going up to 3 at max. Okay, so the memorization part I'll do in this video only. I left it for this, so I'm doing live that memorization part. So the size of the DP array will be n, and the second dimension will be 3 because for that count. And now I have to fill this array dot fill with -1, pass a DP here, and now here we check the, like if DP of I of count is not equal to minus, like a repeating sub problem is found, and if we have already solved it, so return the DP of I count. And here also I'll pass the DP. I think it should be fine working now. Also, I'm doing it live in this video. Uh, okay, index 3 can also be reached. So I have to take 4 here. Okay, no, not 4. Okay, count can be up to n. I can optimize it, but let's first try it for now. Okay, use this test case also. Fine, it's working fine. Yes. So the DP memorization is successful and my streak is now reached up to 396 days. So uh, let's do the optimization which I was talking about. Like we make it as 3 and whenever we can write a base case like if count is ever greater than 3, we can return the large value because we can't go there. There's no point of going there. I think it should work fine now. Let's try. Okay, 3 index is still reaching. Let's do it. 4. Was 3 is also we are taking into account. Now it should work fine. Yes. Yes, we have improved a lot. Like first it was 6 millisecond and then it went to 2 millisecond and earlier it was time limit exceeded. So this approach was n into 4 which is equivalent to O of n only and similarly for the space also n into 4 which is equal to n only. Okay, that's it from my side and this video was completely unscripted and unedited. I'm posting it as it is because I just have want to keep it for my record and my communication practice. Right now, I have no plans to make content for students and for the teaching sake. Also, if I can see any other approach or the any other approach, I think it will be maybe some brute force. Okay, if I found any other approach, I'll upload that. That's it from this part.